The traffic light itself is a solution because when the red light is glowing, all of us has to stop. When the green light is glowing, all of us has to move forward. But why there is a traffic constable in place? Suppose if somebody is not following the traffic rules, he will control them, right? So even after implementing the solution, we have to make sure there is a control plan in place so that the solution is regularly monitored and make sure it is not deviated from the original path. So you will see how to implement the solution, how this solution is implemented properly in the control phase. See, there are 3 steps in the control phase. Okay, the first step is quite important. The last 2 is just a formal one. The 13th step, that is the first step of the control phases. You have to implement the control system for the critical X factors, which may create a performance gap in a process. See, I have identified a critical X factor which has created a performance gap. Now I have implemented a solution to overcome that process, overcome that problem. Now I have to make sure that critical X should not create a problem once again. Okay, for that I need to develop a control system and implement a control system to keep it under control. Okay, so for example, the inventory problem has been sorted out by a solution, but I have to make sure that the same inventory problem should not rise again. Okay, for that I need a control system in place. I need some signaling system. Okay, so that is what we are going to do in the control phase. And after that, everything must be documented. That is important in organizations, in any company. Everything will be documented. Even the entire process of Six Sigma phases, define, measure, analyze, implement, control, should be documented. Then only people who are coming after that will be able to use them for training and will be able to understand the purpose of the project. And after doing that, the entire process should be transferred to the process owner, to the sponsor, so that the Six Sigma team can close the project and move to the next one. So let us see how this control phase can be executed. See, in the control phase, you need to have 4 outcomes. The important one is developing a control plan to monitor and sustain the improvement. We have created an improvement, right? See, there is a problem in the cycle time. The cycle time is more. The cycle time is nearly 25% more. As a result of that, my productivity is less. My customers are not happy with the delayed delivery. So what I can do? Say I have implemented a solution so that the cycle time is now only 80%. So I have reduced it. My productivity is more for the first month. Now I have to make sure that the cycle time remains in the reduced way. Now I have reduced the cycle time by 25% and my efficiency is very good. The performance of the process is good. I have to maintain that. How to maintain that? For that, we need to make sure it is monitored properly. If there is any deviation, immediately we have to attend that and sustain the improvement. That is the purpose of this control plan. Okay, and apart from that, you can use control charts to find out the presence of any special causes. Okay, you would have discussed that also. Then documentation, that is what I told. It is important for people to understand what has happened and can be used for training and can be used for replication and standardization. Once there is a documentation of a solution, once there is a documentation available about a problem and how the solution is arrived, it can be used for other department, right? Okay, like copy paste. Okay, that is how this control phase will be helpful in the Lean Six Sigma process. See, one of the important control phase activities is okay. So previously my operator was not drilling properly. Okay, he is drilling for example, the 20 mm hole. For a 20 mm hole, he may be drilling 19.9 mm or he may be drilling 20.1. So I can put a control system like this. Okay, this is called okay. It will prevent the errors. See, for example, in this system, on the left one, my controller, my drilling operator, he cannot control the depth of the drill. Now I put a stop rod here. You can see the blue one. So what happens when the operator drills for 20 mm, automatically the stop rod will hit the surface. So the drill bit won't go beyond 20 mm. So I got the required depth. Now it is safe. And apart from that, if you want to improvise it, you can add a stopwatch. Okay, you can add a limit switch so that when the stop rod hits the surface, when the drill bit reaches 20 mm and the stop rod hits the surface, the buzzer light will glow. So my operator will understand, okay, I have drilled for 20 mm and he won't rotate the hand wheel more. As a result of that, the particular process is safe. Okay, my process remains safe. So this okay will help you to stop the process from deviating. And here, similarly, we have so many other examples. Like this one, you can see a plug. If there is no indication, the plug may be inserted wrongly. As a result of that, there may be a short circuit. But if there is a indication like a larger one and a smaller one, we will be able to insert the plug properly in the socket. Okay, similarly, for example, the stove and the plug points you can see. If there is proper indication, that will help you to avoid unnecessary process deviation. Okay, you will see some more examples also. Here you can see, you would have seen this normally in the SIM card. In the SIM card on the top right corner, there will be a small serration. There will be a margin trimmer. Margin will be trimmed, right? So that it will be easy for you to insert the SIM in the mobile in the correct position. So this is a okay. In this case, you will be having a confusion. But now it will be easy for you to avoid the error. That is what control plan help you to avoid unnecessary errors, to avoid special cause errors. And similarly, if you take components moving in a conveyor, so in the left one, you can see sometimes an unmachined component also may move along the conveyor. So to avoid that, we have a limit switch mounted on the conveyor in between for every 10 meters. So what will happen when the unmachined component, if it passes the limit switch, automatically it will excite a glower, and the glower will, and the bulb will glow red. So automatically the person who is operating it will be able to understand and remove the unmachined component. So this kind of okay will help you to keep the solutions, will help you to keep your improvement intact, will avoid unnecessary mistake. So these are mistake proofing. The purpose of okay is to avoid the mistake. So it is called a mistake proofing system. Similarly, in audio video systems, you have different colors. Why? To avoid plugging different cables into the different slots. So if there is a color, it will be easy for you to identify which cable has to be plugged into which slot. So these are all okay systems, okay activities, which will help you to keep the system under control and maintain the improvement which you have gained as a result of the improved phase solution. Okay, it avoids the error. So as a result of that, your process will remain under control. It avoids the error automatically. Okay. Similarly, you can have warning okay, or you can have control okay, depending upon the requirement of your organization, of your company, of your process. A warning. So you can see on the left hand side there is a warning okay. The warning okay, the efficiency is very less. Okay, but in the case of control okay, there is a gate on the two sides of the railway crossing. So people are not able to cross. So the percentage of accidents comes down. So you can have warning okay and control okay so that your systems remain intact. Similarly, these are all common in restaurants. Sometimes the wash basin may be full of water and it may be overflowing. As a result of that, the wash area floor may be full of water. To avoid that, if you have a small hole on the wash basin, the water which is stagnating will drain out of this particular hole. So as a result of that, your floor remains safe and the customer remains safe. So these are the things which will help you to improve your customer satisfaction. If there is a wet floor and the customer will be unhappy, sometimes he may fail. So to avoid that kind of situations, you can develop this kind of okay systems. See, in okay, you will be having warning okay, you have control okay, we have shutdown okay. That is, for example, if you are putting an ATM card in a machine, okay, if you are putting only 3 numbers, it will give a warning. It will ask you to put 4 numbers, or it will ask you to put 6 numbers. Okay, suppose if you are typing a wrong PIN number, okay, it will throw you the card and say you are typed the wrong number. Suppose if you are typing the wrong number again and again, it will shut down the entire account, or it will shut down the entire card, and it will say you have to contact the branch. Okay, so this kind of okay will help your system to maintain mistake proof. So that is what we need. We have identified solutions. We need to maintain the improvement which we have gained after a lot of hard effort. For that, this kind of systems will help you to do that. For example, if my operator is not, for example, the night shift, this may happen. The operator may not be very neat. He may be very tired. He may be feeling sleepy. At that time, a component may be manufactured with incorrect dimensions. Okay, he may give his hand, he may unnecessarily give a hand to the machine. So if we have okay systems, that kind of mistakes can be prevented. Okay. So now this kind of okay is a part of the control plan that will help you to keep the system under the control and maintain the improvement through the solution which we have implemented. Okay, now after all these stages, we go for documentation of each and every activity which we have done in this Lean Six Sigma process. Okay, starting from define, measure, analyze, improve, and control, we have to document everything. Okay, once the documentation is done, it will be as a it will act as a dictionary for the people who are referring it, so that they can implement them in other department also. One department may have done a solution. One department might have generated a solution for a particular problem. Okay, that solution can be utilized for other department either in a modified form or in the same form. If it is used in a modified form, that is called standardization. If it is used in the same form, that is called replication. So documentation is quite very important. It can be used for training purpose. It can be used for standardization or for replication. So once you have completed the entire documentation process, you can hand over the documents along with the standard operating procedures, flow charts, and process control plan, response plan, risk plan, mitigation plan to the process owner or to the chairman or to the general manager who is responsible for the particular process. And with that, we close the project. Okay, thank you, gentlemen. If you have any queries, you can ask myself and Dr. Sivakumar will be happy to answer you. Any questions?